Welcome back to Teaching Statistical Thinking with Social Media. In this video, we're going to tackle teaching scatter plots, correlation, and regression for linear models. These topics will take several days to teach. Today, we're going to spend our time learning how to break down correlation and regression for high school students. I'll start with correlation and then move on to regression. Correlation is a tricky subject to teach. In Dr. Stengel's video, you learned how to estimate correlation coefficients by drawing a standard deviation line in 4 quadrants. In this discussion, I'll walk you through some helpful tips for teaching students how to interpret correlation coefficients and how to estimate these. Tip number 1, use the vocabulary words negative, positive, strongly correlated, weakly correlated, and no correlation. Some students quickly become disoriented when they first hear these terms, and it will be important for you to help connect students' knowledge of graphing lines to these new concepts. At this point in the math curriculum, all students have learned about negative and positive slope. Build off this knowledge by showing students that the correlation coefficient is negative if the slope of the line of best fit is negative, and is positive if the slope of line of best fit is positive. For example, if your students plot their data and identify a line of best fit that looks like this, you can ask them what the slope of the line might be. If they say that the slope is positive, you can reiterate that this means that the correlation coefficient, also known as R, is also positive. Similarly, R is negative if the slope of the linear model is negative. Also explain that the further spread out the points are, the closer to 0 the correlation coefficient is. If the points look like an O, the correlation coefficient is close to 0, which is easy to remember, O and 0, no linear relationship. If the points are bunched together around a line, then the correlation coefficient will be close to 1 or -1, meaning that the two variables are strongly correlated. If the points still make a positive or negative linear pattern, but are spread further apart, then the two variables are weakly correlated. And if the points are all over the place with no discernible linear pattern, then the variables are not correlated at all. Tip number 2, save the calculator for later. The graphing calculator and JUMP are important tools in helping students understand and compute correlation and linear regression, but it's important that students build a conceptual framework before using the calculator. The last tip is tip number 3, emphasize that correlation is not causation. Remember that we are actually doing statistics here. It's easy when teaching this material to get caught up in the techniques and forget that we want to be showing students how to interpret data. One of the most common conclusions that students make is that correlation means causation. We've created a lesson plan in the resources section that helps challenge this idea. One of my favorite examples is a scatter plot that correlates the decrease in number of pirates with the increase in global temperature, which implies that a lack of pirates has caused global warming. In reality, what's happening is that as time goes on, the global temperature is going up and the number of pirates is going down. That doesn't mean that the two things are related. For additional examples, check out the resources page. And finally, practice is very important for building the intuition to estimate correlation coefficients. To facilitate more student practice, please direct them to the correlation game in our applet resource page. Linear regression can be tricky for students. In most pacing guides, regression comes immediately after learning the slope-intercept form of a line. While some of your students might be ready to use the formula for a regression line, some students might need to manually create a line of best fit first. When I teach this, I like to use graphing paper and a straight edge. Let's say that you've given your students some data representing the number of Twitter followers in time. In order to find an approximation of the line of best fit, have the students place the straight edge so that about half the points are above their line and half are below. In this particular example, my regression line appears to be here. You'll find that eyeballing regression lines is surprisingly accurate and also helps build intuition about linear models. From this, students can estimate the slope of the regression line and estimate values for new points using interpolation. After students build some intuition regarding regression, the graphing calculator and JUMP are excellent ways of showing students more authentic methods of collecting and interpreting data. Many end-of-course exams are calculator active, meaning that students need practice creating scatter plots and using the tables on their calculators to make predictions. Please see the course's satellite videos to better understand how to facilitate student exploration of these concepts using the calculator or JUMP. Finally, remember that there are other types of regression than linear, including quadratic and exponential. Some standards require students to be able to determine which type of regression is the most appropriate based on the data. Using the built-in functionality on graphing calculators, you can show students that whichever model's R-squared value is closest to 1 is the most appropriate model. A whole period of math can be a long time for both students and teachers. Classroom surveys are a relatively quick way to collect data and to get the classroom moving. In this sample activity, students will collect data about their weekly online video usage and time spent participating in extracurricular activities. The week beforehand, ask students to record how much time they spend watching videos online each day and how much time they spend participating in extracurriculars. Or, if you don't have the time, you can ask them to estimate. Here's an example student table. Students' totals will represent the x and y coordinates of their point on the scatter plot. In class, they need to collect points from at least 10 other students to create a scatter plot and a regression line. Now we're going to use an example data set to walk you through some questions that go along with the activity. Our first question asks students to estimate and draw a star on the point of averages. It then requires them to look at their point and the average point and compare the two. I have put a star on the point of averages and an X on our sample student's data point. It appears that the student watched less hours of online video and participated in more hours of extracurricular activities than the average student. The second question asks if they think the model is linear, and to estimate what they think is the correlation coefficient. In this example, the scatter plot displays a strong negative correlation, with an R around -0.9. Our final question requires a little bit more critical thought, because it has students look at a model and see where it breaks down. The question asks, according to your model, if a student watched 100 hours of online videos per week, how many hours would he or she spend doing extracurricular activities? What happens is, when the model hits 100 hours of online videos per week, the extracurricular activity hours are well in the negative, which is impossible. If either of the variables are negative, the model breaks down. Thanks so much for watching this video on teaching correlation and regression. For more lesson plans and resources to teach regression and other topics, please see our resources section.